Well, I think all high school students, including those that come from farms, are probably unaware of the many opportunities there are in the broad field of agriculture. I mean, it employs millions of workers off the farm and lots of opportunities, whether it's science or technology or sales or marketing or communications. Just a wonderful world of opportunity for people.
Welcome to the Arkansas Food, Farms, and Forests podcast, the podcast bringing you the latest on food, fiber, and forestry research from the Arkansas Agricultural Experiment Station, the research arm of the University of Arkansas System Division of Agriculture.
Welcome to Food, Farms, and Forests. I'm Jennifer Fouch. Today we are learning about agricultural education, why it's important, challenges and wins in the field, and the future of ag education involving artificial intelligence. To talk to us about this topic is Dr. Don Johnson, a university professor in the Department of Agricultural Education, Communications, and Technology. Dr. Johnson, thank you so much for taking the time to be with us today.
Well, thank you, Jennifer. Glad to be here.
So your work, your research focuses on human capital development and agriculture technologies. Can you expand on what that means in general and then what that means for you?
Yeah, happy to. Human capital in its largest sense just deals with the pipeline of talent into agriculture. So we deal with the recruitment of students into agriculture majors. We look at effective practices in educating those students and then their success in the job market. So that kind of goes from beginning to end. I'm interested in all of those areas. We've looked several studies on factors that, predict whether students will enroll in colleges of agriculture and major in agriculture, but we've done more studies on their success once they do enroll. I've worked with Chris Estep and former Professor Kate Shoulders on this quite a bit. And my current interest is on microcontrollers in agriculture.
Interesting. So what inspired your passion for ag education in the first place? And then I want to get into how you got into the microcontrollers.
Well, I grew up on a farm in Kentucky, and so that was my childhood. And when it came time for college, I'd always been more interested in the machinery and the equipment as opposed to the plants and the animals. So when I went to major in agriculture, that's what I focused on. Wound up teaching high school agriculture for 3 years after I graduated with my undergraduate degree and really developed a passion for high school agricultural education. Went back and received my master's and PhD focused on ag education and agricultural technology and been working at the university ever since. So I guess it was willed to me by my father.
That is very interesting coming from a farming background that you're more interested in a different aspect of it. Do you see that a lot maybe being a challenge or maybe being something that people don't usually think about, that you think agriculture, well, you think the plants, you think the animals, but there are different aspects of it that you can go into as well?
Well, I think all high school students, including those that come from farms, are probably unaware of the many opportunities there are in the broad field of agriculture. It's an amazing field. I mean, it employs millions of workers off the farm and lots of opportunities, whether it's science or technology or sales or marketing or communications. Just a wonderful world of opportunity for people.
So tell me about your current interest now into the microcontrollers and how that came about.
I really think back on this when I was in graduate school years and years ago on my PhD at the University of Missouri. I had a friend who was in dairy science, and he was doing biomass feeding trials. And one of the things he had to figure out was how to count the number of times a cow chewed the cud after they ate this feed. And he worked for weeks and weeks and weeks to develop a little mechanism and the electronics and the software and so forth that went with that. And really, that would be an ideal job for a microcontroller, which didn't really exist in this form then. But he could have done that job instead of spending weeks and weeks. He could have spent 30 minutes and probably have gotten that whole thing done instead of all the time he spent. So microcontrollers are just amazing devices, and they're able to do lots of things. And my particular interest right now is on exposing students to these things and showing them that you don't have to be a computer programmer to make use of microcontrollers. And I mean, there'll always be a need for computer programmers, don't get me wrong, but this allows students to enter into that and take advantage of what microcontrollers can do without having to be programmers.
And when you say microcontrollers, it can be anything that is doing some type of job that you need to be done. It can be any like small device you would use on whether it's a cow chewing or maybe drone, something like that.
Exactly. Yeah, they're widely used in drones. They're used. I mean, the term is embedded computing. They're computers that are embedded into devices. And the example I always use in class is if you've ever walked on a treadmill and you punch a button and you say you want a steep or you want a lower or you want a pattern of some kind. When you punch that button, what you're doing is you're communicating input to a microcontroller that controls all the motors and the angle and pitch on that treadmill to give you the workout that you've asked for. So we interact with these things all the time. When you punch your button on your microwave to go to rewarm your dinner plate and tell it you want to go at 90%, that's exactly what you're interacting with, the microcontroller that's on that microwave.
Very cool. What is the feedback you receive from students when you first introduce this idea to them or first introduce the technology part of agriculture to them? You mentioned that even some students who come from farming might not even realize the different opportunities that there are within the industry.
Well, yeah, and it's funny you should mention that because we just collected some data today in class, and I had students reflect on their week-long instruction in microcontrollers, and that was the general gist of things. Wow, we didn't know these things existed. Now we see how useful they are. We see that they're in everything, and they're not intimidating to use. They can be, used by people like me. So I think. The big thing is getting students to realize that whatever it is, whether it's my discipline or somebody else's discipline, they're bright people and they can do things if they just set their mind to it and learn. Nobody starts out being an expert, you have to learn, but all of them have the intelligence and the capability to do that.
Why is it important to attract more students to this field, specifically technology, because it is getting more and more involved in the industry as well? Why is it so important that we spread the word about these are the opportunities and get more students into ag education?
Well, USDA does a survey every 5 years that talks about career opportunities for graduates in the food and ag sciences. And uniformly, for ever since they've been doing the study, the number of job opportunities for college graduates in agriculture far outpaces the number of graduates in agriculture to take those jobs. So a lot of those jobs are being filled by people who have good backgrounds in, say, in that business or engineering or whatever, but maybe don't understand how that applies to agriculture. So if we can recruit more of our own students that know about agriculture and learn about these technologies into our program, then they can help fill that gap a lot better maybe than folks who know the technology or know the business but don't know the agriculture part of it.
So job opportunities, you know you're going to have jobs waiting for you.
Absolutely. During the last recession that we had, agriculture was one of the strongest job markets for people even during the recession. So people have to eat, people have to wear clothing, they like to live in houses, all of those things, and agriculture provides those things.
Why do you think that is? Do you think it is just that maybe students don't know about all of the opportunities within agriculture, that we're seeing this gap between the number of jobs and the need and the number of people who are getting connected into those jobs?
Yeah, I think that's one of the roles of high school agricultural education programs to help students to realize the breadth of opportunities there are in agriculture. I think that a lot of people equate agriculture with farming, and farming is a wonderful profession, but most kids don't come from the background where it's capital intensive to get into agriculture. So if they don't come from a farming background or situation, they may not be able to move in to be a farmer. And if they see that as the only agricultural career, then I start looking elsewhere instead of looking at all the other things in agriculture that would be available to somebody with a college degree in agriculture. So I think, again, high school agricultural education has a real important role into broadening perceptions of what agriculture graduates do.
You mentioned that you are currently working with a USDA grant that will allow you to work with high school students. Is this related to your recent study about ChatGPT and microcontrollers? Can you explain what that USDA grant is and how it connects to high school students?
Yeah, certainly. The USDA grant is a grant that we have with Utah State University and with the University of Minnesota. And we have, through this grant, we will develop curriculum materials and hands-on activities that teachers can use with their high school students to expose them to microcontrollers as tools in studying agriculture. We'll also provide those teachers with class quantity kits of microcontrollers and sensors, everything they need to carry out those activities, with the intent that hopefully teachers will see that these are fairly easy to use and really fit into the curriculum as wonderful tools for the study of the scientific and technical aspects of agriculture, and will incorporate those into more classes. We hope to put these in over the 2-year project, 640 classrooms. Or 640 classroom kits, I believe, in 128 classrooms. So that's our goal.
Are those classrooms going to be in Arkansas and Utah?
They're going to be in Arkansas and Utah and Minnesota in equal numbers.
How will those classrooms be selected?
We will put out an announcement that we have this opportunity available. We'll have teachers apply to be a part of the program. Then we'll be selective in choosing those teachers. And what we're really interested in, we want a breadth of curriculum areas that they teach. So not all teachers teaching one subject, but lots of different subjects. And we'll also look to spread those around the state so that they're geographically distributed, so that I can work with, and these teachers will become pilot or train the trainer teachers for a new cohort of teachers in the second year that are local to them. So that's the way we hope to spread this and keep it going after the grant runs out.
Do you have a title for this project?
Yeah, it's called Microcontroller Minds, Integrating Arduinos into Agricultural Education.
Is this grant and this project, Microcontroller Minds, is this connected to one of your latest studies on artificial intelligence and ChatGPT, or can you discuss that study?
Yes, well, we've done a series of study on microcontrollers. Our first one, we just looked at ways to interest students and increase their self-confidence in using microcontrollers. Uh, that was with my colleague at Utah State who's in on the grant here. Once we did that, that was about the time ChatGPT launched publicly in November of whatever year it was, 2022, I believe. And so we immediately thought that, hey, there's potential to use ChatGPT or other forms of generative AI in microcontroller programming, because we quickly learned that it writes a really fine program. And so that kind of switched the focus. Now students don't have to be programmers, but what students have to do is they have to understand the system and have to know exactly what they want the system to do and engineer a ChatGPT prompt that will produce the program that does that. And there's a real skill to that, and it really takes some critical thinking to describe what you want to happen to ChatGPT. And we think that's where the real benefit is going to be. We're not trying to make computer programmers. We're trying to make people that appreciate what microcontrollers can do and recognize them as being ways to solve problems that they may have.
On a broader scale, what role does innovation and artificial intelligence play in attracting and retaining students in agricultural programs?
Generative AI is here. It's not going away. It's only going to become more important. Was at a conference on AI last year, and I don't remember his name, but one of the panelists said, we shouldn't be afraid of generative AI. Generative AI is not going to replace workers. What's going to happen is workers that can use generative AI will replace workers who cannot use generative AI. And so I want our students to be among that group that know how to use generative AI, so that what they can do and know and what generative AI can do, the sum of that is greater than either one could do alone. So that's what I want our graduates to be. I want them to be those people that can use generative AI as a tool to do the things they know how to do, but to do them better, quicker, more efficiently, all of those kinds of things.
You talked about the real world applications and you gave one example of the cow chewing and counting how many times. What are some other examples of how microcontrollers specifically can be used in the field? What can it look like?
Another example I give in class is a lot of my students have baled hay with a round baler, and the round baler beeps or gives you a signal, an audible signal when it's ready to tie the bale or wrap the bale and eject it. And so the tractor operator steps on the clutch and pauses the tractor, takes it out of gear maybe, waits for that to happen. Then you get another beep, the bale's ejected, they drive on down the windrow and make another bale. Well, we have machinery now where the tractor and the baler communicate with each other. So I'm driving the tractor down the windrow gathering the hay. The baler senses the fact that the bale is large enough to wrap now. It sends a signal back down to the tractor that says, "Tractor, stop. I'm going to wrap the bale now." And so the driver's just sitting up there driving, not doing anything. The tractor stops. The bale wraps and ejects. The baler sends the tractor another signal that says, "Hey, baler, you can drive on, or tractor, you can drive on down the windrow now and bale more hay." And again, the operator is there guiding the tractor, but all of those things are happening automatically. So if you bale 300 bales in a day, think of all the steps you've been saved and all the stress you've been relieved of, and you can concentrate on driving a better windrow. You can concentrate on operation of the machinery, making sure everything is running smoothly, and you don't have to worry about those types of things. So that's just another example of tractors and machinery being able to communicate through microcontrollers.
What advice would you give to students or young professionals going into agriculture education, and then people specifically working with the technology that you're teaching? Maybe someone who is interested in specifically microcontrollers.
Yeah, I think I could kind of blend those two questions together. And my advice would simply be don't sell yourself short. You can do a lot more than you think you can do. Okay. You don't have to know everything about a job to become employed in that career. Companies are willing to train you and teach you if you are willing to learn and willing to work and put forth the effort. So, a lot of students are kind of intimidated by all there is to know in a particular occupation or profession. Don't worry about that. You'll learn that. You'll learn that. People don't start out as experts in anything. You learn to be an expert, and they can learn that too. And you don't have to be an expert in everything. You need to be an expert in your particular thing.
Is there anything that you think educators, industry professionals, policymakers even can do to make sure that agricultural education remains relevant, impactful, and that students know that it's out there, know about the opportunities, especially as more technology becomes available?
Yeah, I think there could be more promotion of career and technical education in public schools, and I think that may be for years they went away from that, and it was all college prep. But I don't think there's a dichotomy between career and technical education and preparing for college. Some people are interested in technical and scientific careers, so they can get that background in career and technical education along with their college prep, and they're well suited for a variety of college majors. So I don't see it as an either or. Either you're going to college or you're going to study career and technical education. There's no reason you can't do both and be highly successful. So I think a realization of promotion of that would be a big help.
Well, thank you so much for your time. I really appreciate you taking the time to talk to us and discuss your expertise with us, Dr. Johnson.
I'd certainly appreciate the opportunity to be here and visit with you.
That was Dr. Don Johnson, a university professor in the Department of Agricultural Education, Communications, and Technology, talking to us about ag education. Thanks for listening. I'm Jennifer Fouch. Don't forget to subscribe.
The Arkansas Food Farms and Forests podcast is produced by the Arkansas Agricultural Experiment Station, the research arm of the University of Arkansas System Division of Agriculture. Visit aaes.uada.edu for more information.